Alright, so today we're going to be talking about Chapter 1, Lesson 3, Multiplying and Dividing Monomials. Now, we have a couple of different rules that we can use to help us do this. But the first one we're going to use is called the product of powers, and that's going to be specifically dealing with multiplying monomials. So what it says is A, which happens to be the base, if we remember back from Lesson 2, A, which is the base, raised to m, which is the exponent, times the same base a raised to a different exponent. If we multiply two bases together, they have the same base, different exponents, we can add the exponents and keep the base. A more concrete example is 2 to the 4th times 2 to the 3rd. We would add the two exponents, so 4 plus 3 is 7, and keep the base. The reason why this works is because 2 to the 4th is 2 times 2 times 2 times 2. And 2 to the 3rd is 2 times 2 times 2. If we add up all of those 2's now, because they're all the same base, so 1, 2, 3, 4, 5, 6, 7, this represents 2 to the 7th power. So let's look at some examples. Example 1, r to the 4th times r to the 6th. We keep the base, we add the exponents. So 4 plus 6, this would be r to the 10th. Next example, 7 to the 6th times 7. Here we don't see an exponent, but really what's there is a 1. The reason why is because this 1 says that we have 1, 7 multiplied by itself. And with only 1, 7 being multiplied, it's just there. So we don't really put a 1 here. But 7 to the 6th times 7 to the 1st, so we'd have 7 to the 6 plus 1, which would be 7 to the 7th. And if you think about it, 7 to the 6th power is 7 times 7 times 7 times 7 times 7 times 7. That's this right here. And then we have one more 7 at the end of it. So we have 1, 2, 3, 4, 5, 6, 7 sevens. Example 3, simplify using product of powers rule. So first of all, what we want to do is we want to get this negative 7 and this 11 close to each other. We can use a rule called the commutative property. And what this property says is if I'm multiplying numbers together, it doesn't matter the order that they get multiplied in. So I can actually move things around in a multiplication expression to make it a little bit easier to do. So I'm going to move the negative 7 and the 11 next to each other because those are very similar things. And then I'm going to move the x to the 2nd and x to the 4th next to each other as well. So this is not like one part. Here's our next part. Again, I was able to do that because of the commutative property. So negative 7 times 11 is negative 77. X to the 2nd times x to the 4th would be x to the 2 plus 4, which happens to be 6. So that would be the simplification for that expression. Alright, let's talk about now the quotient of powers rule, or dividing powers. So, same exact thing here, a to the m divided by a to the n. Again, a's are the bases, so the bases are the same. The exponents are different, m and n. It can be written like this, or it could be put in fraction form. But what this property tells us is that if I'm dividing two monomials, I keep the base and I subtract the exponents. More concrete example, 3 to the 6th divided by 3 to the 3rd could also be written in fraction form, 3 to the 6th in the numerator, 3 to the 3rd in the denominator. subtract the exponents, so it's 3 raised to the 6 minus third power, so it would be 3 to the third. And if you think about this, 3 to the sixth is 3 times 3 times 3 times 3 times 3 times 3. And then 3 to the third is 3 times 3 times 3. When we're simplifying fractions, what we're looking for is common factors between the numerator and denominator that we can simplify out. So here is a common factor. There's a 3 in both the numerator and the denominator. Here's another one. Here's another one. These all simplify down to 1. And 1 times 1 times 1 times 3 times 3 times 3 is just 3 times 3 times 3, which happens to be 3 to the third. So in example 4, I have 6 to the 12th divided by 6 to the second. I keep the base. I subtract the exponents, so this becomes 6 to the 10th. Again, if you wanted to write it all out, there are 12 sixes, 4, 5, 6, 7, 8, 9, 10, 11, 12. Make sure they're all being multiplied together. And 2 in the denominator. Looking for common factors, here's 1, and here's 1. They simplify down to 1, so really it's like they cancel each other out. They're gone. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 left over. Example 5, a to the 14 divided by a to the 8th. We have a to the 14 minus 8, which would be a to the 6th. Now with example 6, it's a little bit more difficult because we have numbers out front here. But what I like to do is kind of draw lines in between each little section. Now, this first section, do not get it confused. This is a simple division problem. If I were to simply cover up these two terms here, I'd have 36 divided by 9, which happens to be 4. Do not do subtraction here. Subtraction only comes into play when we're doing exponents, and only the exponents get subtracted. So in this next section here now, we have x to the 4th divided by x. So there's really a 1 here. So 4 minus 1 is 3. And this last section, y to the 3rd, here's another 1. So y to the 3rd divided by y to the 1st would be y to the 3 minus 1, which is 2. And that's the end of lesson 3. If you have any questions, please let me know.